In this video, we're going to go over how we find the intersection point of two graphs using the graphing calculator. So let's suppose that these are the two functions we want to graph and we want to find their intersection points. So let's grab our calculators, turn on your calculator, and it's a good idea to clear the memory of your calculator before you start, because who knows what you may have previously been doing on your calculator, and sometimes there's things that will interfere with what you're trying to do, or it's just a messy set of stuff you have to get rid of anyway. So let's clear the memory. I want to show you an example of something that could interfere with what you are trying to do. So if you go into y equals, you'll see there's already some equation there we don't want. And you'll also see that there's a stat plot turned on. You see plot 1 is highlighted. Sometimes if that's the case and you're trying to graph something else that's not associated with the scatter plot, you may have trouble getting your calculator to graph. So to avoid those kinds of difficulties, we're going to reset the memory, which is second plus for memory, number 7 reset, all RAM, number 2 reset. Okay, now when we go into y equals, you'll see it's clear and there's no scatter plot turned on. So let's type our functions. The first one was y equals x squared minus 6x plus 8. And the second one was y equals 1/3 x minus 1. Okay, so we have a parabola and we have a line and we want to see if they intersect at any particular points. This method using the calculator, if we're lucky, might give us exact coordinates of intersection points, but at the very least it will give us approximate values of intersection points. Before we can look at the graphs, we need to determine a good viewing window. We could start by pressing zoom and pressing standard. Zoom standard is zoom 6. And this is not a bad viewing window because we do see both graphs and we do see their intersection points. But if you wanted an even better window, you could fiddle with the numbers a little bit, and that's what I have done. So I'm going to change my window. For x min, I'm going to use -1. For x max, I'm going to use 5. For y min, I'm going to use -2. And for y max, I'm going to use 3. There's any number of different possibilities that will be a good window for these graphs. That's just what I happen to pick. Okay, now we're going to look for both intersection points. So notice there are two. So we're going to start by looking for this one, and then after that we're going to look for this one. So what we do is we press second trace. Second trace takes us into the calculate menu. Choose number 5, which is intersect. See that right here. And then the calculator will ask you 3 questions. The first question is the cursor on the first curve? Notice the cursor is on the blue curve. It doesn't matter if the blue curve is the first or the second curve. That is one of the curves you want. It also shows you right here that the calculator is on y1. So to say yes, we just press enter. Now the cursor moved to the other curve. And it asks you the second question. Is the cursor on the second curve? Yes, it is. We can tell it is, and we can also tell because of the y2 up here. So we press enter to say yes. And now for the third question, it wants a guess. Guess the intersection point. And what it means by guess is move the cursor closer to the intersection point. And you don't have to put the cursor exactly on the intersection point. It doesn't even need to be close. You just want to make sure it's closer to the point you're looking for than it is to the other point that we're not currently looking for. So I could move the cursor closer to the intersection point. It doesn't have to be right there. It could be over here. It could be way back over here. It doesn't matter as long as it's not over at this one for now, because right now we're looking for the one on the left. So don't worry about that too much. Just put it somewhere and press enter. And then you see at the bottom of the screen the coordinates of the intersection point, but these are definitely approximate values. So if you're doing a problem and you're required to get exact intersection point values, you're going to need to do it algebraically, but if approximate coordinates are okay, then this is fine. Okay, we're going to repeat the process to find the other intersection point. So we press second trace again to take us back into the calculate menu, and again we press number 5 for intersect. And then it asks you the three questions. So is the cursor on the first curve? Well, if you can't tell and you forget to look up here, one thing you can do is use your right and left arrow to move the cursor along the curve it's currently on, and you can see which one it's on a little bit better. So we'll call that the first curve. We'll say yes, so enter. And now is the cursor on the second curve? Yes, it jumped to the other one, so we'll press enter for yes. And now let's give it a guess. So just move that cursor over closer to the other point, or you could type in a number. You could say type in 3 if you wanted that cursor, or 4, whatever that is. If you wanted that cursor to be closer to that point, press enter. And here we have the approximate coordinates of the second intersection point listed at the bottom of the screen. You might be wondering, why does it ask you for the first curve and the second curve when there are only two curves? But just imagine that perhaps you're doing a different problem where you have 3 curves drawn or more, and you just want the intersection point of 2 of them. This way you can identify which ones you are looking for. So that's it. That is finding the intersection point of 2 curves using your graphing calculator. Thanks.